Alright, so let's say we take 1 million particles, so that's going to be 10 to the power of 6, and I want to work out how many moles there are, so I'm going to divide that by 6.02 times 10 to the power of 23, and that is going to give me 1.67 times 10 to the power of 18 moles. Alright, so this value here is quite a large number. Okay, conversely, if I have 1.5 moles, how many particles will I have? Okay, so I'm going to times that by Avogadro's number, and that will give me 9.03 times 10 to the power of 23 particles. So how can we now apply this to an element? So let's say we pick an element. Put in a heading here. So I'm going to pick on copper. So I go over to my periodic table and I find that its mass number is 63.55 grams. Well, that's its relative atomic weight. Alright, so how many moles if I take 10 grams of copper sulfate? How many will I have? So I'm just going to do 10 divided by 63.55, and that will give me 0.159 mole. Conversely, let's say I had 12.5 moles of copper. How much mass would I actually have? Alright, so I'm going to rearrange my little equation. So mole equals mass divided by relative molecular weight or atomic weight. So just rearrange that. So mass is going to equal moles times relative atomic weight. So that's going to be equal to 12.5 times by 63.55. So up here, that was you get that off the periodic table for its weight. So that would actually weigh 794.38 grams. What about a molecule? So here is chlorine gas. Now, its molecular weight is going to be twice that of the chlorine atom. So this is how chlorine is found in nature. So they're chemically bonded together, a diatomic molecule. So its relative molecular weight is going to be equal to 35.45 times by 2. So the weight of this molecule here is going to be 70.9 grams per mole. Right, so if you're doing really big molecules, so let's say we take a carbohydrate, so C6H12O6, so that could be a carbohydrate like glucose. How would I work out its molecular weight? Okay. The key thing is when you're typing it into the calculator, you must use brackets and type the whole thing. So I've got 6 carbons here, so it's going to be 6 times 12.01 because that's the relative atomic weight of that. Again, where did I get this number from? Periodic table. Plus 12 times 1.008 plus 6 times 16. Type it exactly like you see there with the brackets. If you do make a mistake, which is quite common when you do these large molecules, you can always go back and edit them. And this will give me a molecular weight of 180.156 grams per mole. Okay, so let's have a look at this now. Combustion of propane. So here's the formula for propane: oxygen, water, and carbon dioxide are the products. So the first thing that we must do is actually balance this equation. Now, because we've got an element by itself, we leave that one to last. That's our wild card when it comes to balancing equations. Alright, so I've got 3 carbons. I need 3 carbons over here. I've got 8 hydrogens, so 4 2s are 8 hydrogens. So now how many oxygens do I have? So there's 4 there, and 3 2s are 6. 6 plus 4 equals 10. Oxygen comes in packets of 2, so I'm going to stick a 5 out the front there. Okay, so here's the question. How much carbon dioxide will I produce if I burn 10 grams of propane? Okay, so the first thing we need to do is to convert this into particles, aka moles. So what is the relative molecular weight of propane? So that's going to be 3 lots of carbon plus 8 lots of hydrogen. So that's going to give me a relative molecular weight of 44.094 grams per mole. Alright, so if I want to convert this into actual moles, then moles is equal to mass over relative molecular weight, which equals 10 divided by 44.94, and that's going to give me 0.227 mole. Now, if we look at the ratio of this, technically there is a 1 there. So the ratio of propane to carbon dioxide is a 1 to 3 ratio. So we're going to multiply this by a 3/1 ratio. Okay, and remember the trick, if it gets bigger, then the fraction has to be bigger. So that means the moles of carbon dioxide is going to be equal to 3 times the moles of the propane, which is equal to 0.227. Now if I times those two together, that gives me 0.681 moles. Now if I want to convert moles into a particular mass, so mass is equal to moles times by relative molecular weight. So I've just rearranged the equation there. What is the relative molecular weight of carbon dioxide? So that's going to be 12, put a label there, 12.01 times by 2 times 16, which is the weight of oxygen. So that's going to give me a molecular weight of 44.01. So mass is going to equal to this value here, so 0.681 times by 44.01. So the mass is going to be equal to 29.97 grams. But considering I'd probably round that off to 30.0 grams if I was doing 3 sig figures. Okay, and that is it.